All right, we're going to continue talking about trigonometric functions. All right, so figure 5.15 illustrates the degree and radian measures of angles that you will commonly see in trigonometry. Each angle is in standard position so that the initial side lies along the positive x-axis. We'll be using both degree and radian measures for these angles. So again, the sooner you memorize that unit circle, the better off you're going to be. Now, I don't ever memorize the negative one just because it's too much for me to memorize. If you memorize the positives, all you have to do to get to the negatives is reflect. For example, watch. If I want to, there's a positive 30 degrees, which would be pi over 6 radians. If I want to go a negative 30 degrees, it would be down here. Okay, but instead of having to worry about that, notice that if this is positive, you just reflect down, and this would be the negative. If this is positive 45, then this is negative 45. If this is positive 60, then this is negative 60. And you see how it goes from there. Okay? Alright. So again, with our unit circle, we've got our axes. We've got all our denominators are 2's. We've got the outside numbers going 1, 2, 3, 1, 2, 3. The bottom numbers going 3, 2, 1, 3, 2, 1. We've got the inside numbers going 3, 2, 1, 3, 2, 1. On bottom, we've got in reversing order going 1, 2, 3, 1, 2, 3. Radical dude, all the 2's and 3's get radicals. Signs, everything's positive in first quadrant, x's are negative in the second quadrant, both are negative in the third quadrant, and y's are negative in the fourth quadrant. Then you've got your degrees, add 30, add 30, add 15, add 15, 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 add 30. Radians, in the first quadrant, your denominators, or your numerators, sorry, from the top go 3, 4, 6, your denominators, my bad. And on the tops, or the bottoms, you go 6, 4, 3. The tops in quadrant 1 are all pi. In quadrant 2, you add 1 to the bottom and put a pi on it. So up top would be 4 pi. In the middle would be 3 pi. I'm sorry. You subtract 1 and put pi on there. So 3 take away 1 is 2 pi, 4 take away 1 is 3 pi, 6 take away 1 is 5 pi. You add 1 and a pi to quadrant 3. So 6 plus 1 is 7 pi, 4 plus 1 is 5 pi, 3 plus 1 is 4 pi. And in the fourth quadrant, 5 days a week, I go to 7, 11. And your quadrantals, you start with 0, you go to pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And there's your unit circle. Alright, so we have to draw and label each angle in standard position. Well, you've got your pi over 4. Use your unit circle. That's the one that's in the middle. So to draw a standard position, you put your initial side on the x-axis, your terminal side at 45 degrees. There's your theta of pi over 4. Okay, for B, we're going to go to positive 5 pi over 4, which is right here. So our initial side is on the x-axis, and 5 pi over 4 would be here. And then you always put your direction there with an arrow. Okay, so now we're going to go to negative 3 pi over 4. Again, I don't like to memorize the negatives, so I just go to 3 pi over 4 and then reflect down, which would put me there. So again, I'm drawing this angle, but I'm going this way this time. That would be a negative 3 pi over 4. The other way you can think about it is you can go, well, look, if you look at these kind of like a community, a town that was built in a circle, and these are people's houses or businesses or whatever you want to think them as. If you went to positive 3 pi over 4, you would have to take 1, 2, 3, 4, 5, 6 steps going counterclockwise. So if you're going to go negative 3 pi over 4, you would take 6 steps going clockwise. 1, 2, 3, 4, 5, 6, and that puts you right here. That's the other way you can think about it. Alright, What the heck with D? 9 pi over 4. I don't see any 9 pi over 4s. The biggest over 4 I see is a 7 pi over 4. So how in the heck am I supposed to get to 9 pi over 4? Well, you're going in a circle, guys. So if I figure out how many 4s are in 9 pi's, 4 goes into 9 2 whole times. Take away 8 leaves 1 pi. So my answer would be 2 whole pi's plus another pi over 4. That's what this equals. 2 pi plus another pi over 4. So to graph this, what you do is you say, well, there's 1 pi, there's 2 pi's, so I've done this much. Now I need to go another pi over 4, which is 2 houses, 1, 2, and it puts me right there. What tells me that it's not just pi over 4, that it's 9 pi over 4, is my arrow showing that I went all the way around once and then went an extra pi over 4. Okay? Alright, so you try this one, hit pause, come back when you're ready, and hopefully you got C. If you did not, if you look at it, 2 pi over 3 is right here. So to draw that angle in standard position, you put your initial side here, and you go to that mark there. And there is 2 pi over 3. Okay, try this one, hit pause, come back when you're ready. And it's got to be this one, because 405 degrees is more than 360. If I take 405 and I subtract 360, I get 45 degrees. So I have to go a whole 360 plus another 45 degrees. So see how this shows that I went all the way around once plus another 45 degrees? 45 degrees is right there in the center. But what makes it 405 degrees instead of 45 degrees is that I went all the way around plus another 45 degrees. Okay? Alright, so coterminal angles. Coterminal angles are just like we saw. If I look at 45 degrees and I look at 405 degrees, we call those coterminal angles because they have the same terminal size. The difference is how far you traveled. If you only go 45 degrees, you've only taken 2 steps. Whereas if you travel 405 degrees, you're in the same position when you stop. You're still right here. You're in the exact same position as the blue guy, but you had to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 steps. So you traveled a lot farther, but you have the same terminal side. That's why they call it coterminal. Share, same, with, same terminal side. Okay, so to find them, if you're in degrees, you simply start adding 360 or subtracting 360. If you're in radians, you're going to add 2 pi to get a positive and subtract 2 pi to get a negative. Because in a whole circle, right, a circle has 360 degrees in it. So if you stop here and you go 360 degrees more, you'll be in the same position. Okay, same with 2 pi, because 2 pi is the same as 360 degrees. So it says, assume the following angles are in standard position. Find a positive angle less than 360 that is coterminal with each of the following angles. A 420 angle. They want a positive angle but less than 360. I mean, I could get a whole bunch of more coterminals. I could just keep adding 360 and add 360 and add 360. But they want one that's positive but less than 360. You can also get coterminals by subtracting. So if I subtract 360, 420 minus 360, I get 60 degrees. Now watch. If I go 420 degrees, that would be 360, 370, 380, 390, 400, I can't count very well, 400 and I did 30 to 15. Where was I at? 360 plus 30 is 390 plus 15 is 405 plus 15 is 420, which would put me right here. So there's 420 degrees. 60 degrees would be here. Do you see that they have the same terminal side? 420 and 60 degrees are coterminal angles. Okay, so now we've got negative 120. Well, positive 120 is up here, so negative 120 would be down here. So there's your negative 120. Okay, I want a positive coterminal angle. To get to a positive means I'm going to need to obviously add 360. So if I do negative 120 plus 360, I get 240 degrees, which, if you look, 240 degrees is right there, but I'll be going this way. So my traveling is different. My direction and how many steps I take is different. But do you see how they have the same terminal side? So 240 degrees and 120 degrees, negative 120 degrees are coterminal angles. If they give it to you in pi, all right, they want a positive angle less than 2 pi that is coterminal with each of the following. So if I want a positive coterminal angle, but I want it less than 2 pi, I'm going to subtract 2 pi. That would be over 1. So I need to get a common denominator, which will be 6. So I'm going to take away 12 pi over 6. If I have 17 pi over 6, take away 12 pi over 6, I end up with 5 pi over 6. So if I graph those, if I graph 17 pi over 6, we'd have to figure out how many times 6 goes into 17 pi's, which would be 2 whole pi's. That would be take away 12, which would leave 5. So you're going to have 2 whole pi's plus another 5 pi over 6. So to graph 17 pi over 6, I would go 1 pi, 2 pi, plus another 5 pi over 6, which is right here. In green is my 17 pi over 6. In blue is 5 pi over 6, which would just be from here to here. So you can see in blue, I had to travel a lot less, but I ended up in the same position, which means those angles are coterminal. So if you have a negative pi over 12, alright, and that's not in my unit circle. Ooh, how are we going to graph that one? Negative pi over 12, if I want to get a positive coterminal angle, I'm going to add 2 pi. To get a common denominator, I'm going to multiply by 12, which would give me 24 pi over 12. So now I have negative pi over 12 plus 24 pi over 12, which gives me 23 pi over 12. And those would be coterminal. And I'm not going to graph those because those are not in the unit circle. I'm just a pain in the butt. We could convert them to degrees and go estimate it, but we won't. Alright, so you draw, or you don't even have to draw this. They just want you to find a positive angle less than 360 or 2 pi that is coterminal with the given angle. So hit pause, come back when you're ready, and hopefully you got 49 degrees. If I want a positive angle that's less than 360 and I'm already negative, I need to start adding 360s until I get to a positive. So I have negative 1031 plus 360. That gives me negative 671 degrees. That's coterminal. Every time I'm finding these, I'm finding a coterminal angle, but it doesn't meet my criteria yet because I want a positive one. So I'm going to add another 360. And I get negative 311. So that's also going to be coterminal. If I add another 360, I get positive 49. So 49 degrees is also coterminal. And I could keep doing this all day. I could keep generating coterminal angles until the cows came home. You just keep adding 360 and you'll find another one. Or subtracting 360 and you'll find another one. But this one is the first one that's positive and less than 360, so that's the one they're looking for. Alright. Try this one. Hit pause. Come back when you're ready. And hopefully you got 7 pi over 5. Alright, they want a positive angle less than 360 or 2 pi. So we're looking, since we're in radians, something less than 2 pi. This is not less than 2 pi because 5 goes into 17, 3 whole pi's and something left over. So that tells me that I need to subtract 2 pi. But that means I need a common denominator, which would be 5. So that'd be 10 pi over 5, 17 pi over 5. Take away 10 pi over 5 would be 7 pi over 5. That would be coterminal to 17 pi over 5. Yeah? Alright. The length of a circular arc. We've already seen this formula. If you want to find arc length, you take the radius times theta. The way we had it yesterday, they said theta equals rs divided by r. And all they did was manipulate this to get theta alone. If I got theta alone, I divide by r. There's where they got theta. They just manipulated it so that there's not a fraction in it. Okay? Same formula. Alright, so it says a circle has a radius of 10 inches. Find the length of the arc intercepted by a central angle of 120 degrees. That would be about 120 degrees, and they want me to find this arc length. The problem is, this formula is when theta is in radians. If your theta is in degrees, this formula isn't going to work. You can't plug in 120 for theta. You've got to convert it to radians. So I say 120 degrees. I want to get rid of degrees and go to radians. There are pi radians in 180 degrees. Degrees cancel, and I end up with 120 pi over 180. If you take 120 divided by 180 and math enter that, you get 2/3, which gives me 2 pi over 3. Okay, so there's my theta in radians. My radius is 10 inches. And my arc length is what they're trying to figure out. So now that I have everything in the right dimension, I can use this, which says my arc length will be my radius, which is 10, times my theta, which is 2 pi over 3. So my arc length is going to be 20 pi over 3. So my arc length is going to be approximately, we're going to round, 20 pi, enter, divided by 3 is going to be, oh, wait a sec. Yeah, make sure that your mode is in radians or you will not get the right answer. So my arc length is going to be 20.94 inches. Okay? Alright, so this one says the minute hand of a clock is 2.5 inches long. Okay, you got the hour hand and then you got the minute hand. Okay, I'm not really concerned about the hour hand. This is 2.5 inches long, so we're going to call that the radius of the circle. And it says how far does the tip of the minute hand move in 35 minutes, so it's going here. Okay? Well, I need to figure out that angle. Well, the whole circle is 360 degrees. If I cut that into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equal pieces. Yeah, if I divide that into 12 equal pieces, 360 divided by 12, each 5 minutes is 30 degrees. So there, my theta would be 30, 60, 90, 120, 150, 180, 90, 200, 210. So my theta is 210 degrees, right? 7 times 30 is 210 degrees. Again, I need to turn that into radians, so if I want to get rid of degrees, I put it on the bottom, radians on top. pi radians, 180 degrees, degrees cancel, I end up with 210 pi over 180. 210 divided by 180, math, enter, you get 7 pi over 6 radians. So, and I don't know my arc length, which is what they want to know. They want to know how far did the minute hand travel. Well, that's the distance around the clock from here to here. So they want that arc length. So arc length equals the radius, which is 2.5, times my theta, which is 7 pi over 6. So my arc length is 2.5 times 7 pi divided by 6, and I get the arc length is 9.16 inches. Okay? Alright, it says a wheel with a 25-inch radius is marked at 2 points on the rim. The distance between the marks along the wheel is 14 inches, so they're giving me the arc length. And they want to know what is the angle to the nearest tenth of a degree between the radii of the two marks. So they want me to figure out theta to the nearest degree. So we've got to be careful again. Well, we know that arc length is 14 equals my radius, which is 25, times my theta. So to figure out theta, I divide by 25. And I get theta equals 14 over 25 radians. But they don't want radians, they want degrees, so I have to convert. If I want to get rid of radians, I put radians on the bottom, degrees on top. There's pi radians in 180 degrees, radians cancel, and I end up with 14 times 180 over 25 times pi degrees. So if I do that, 14 times 180, enter, divided by parentheses 25 pi, and I get about 32.1 degrees to the nearest tenth, because it says 32.08563653 to the nearest tenth. The 8 would bump it up and be about 32.1 degrees. Okay, you try this one, hit pause, come back when you're ready, and hopefully you got 19.8. Alright, so they want the length of the arc on a circle. They gave us the radius, they gave me theta in degrees, and for this formula to work it has to be in radians. So if I turn 120 degrees into radians, get rid of degrees, go to radians, pi radians, 180 degrees, degrees cancel, I end up with 120 pi over 180, 120 divided by 180, math, enter, you end up with 2 pi over 3 radians. So my arc length is going to be my radius times 2 pi over 3. So if I take 9.11 times 2 pi, enter, divided by 3, I get the arc length is 19.07993938. 2 decimal places, the 9 bumps the 7 up, 280. Okay? Alright, try this one, hit pause, come back when you're ready. And hopefully you got 10.47 inches. Okay, my minute hand this time is 4 inches long. How far does the tip of the hand move in 25 minutes? Remember we said each one of these was 30 degrees, so 30, 60, 90, 120, 150. Right, so theta is 150 degrees, and they want me to find the arc length. Well, I can't use degrees in this formula. So 150 degrees, degrees to radians, pi radians, 180 degrees, degrees cancel, I end up with 150 pi over 180. So 150 divided by 180, math, enter, you get 5 pi over 6 radians. I can use my formula and say that arc length equals my radius times my theta. And if you do 4 times 5 pi, enter, divided by 6, you get 10.471975551. 2 decimal places, one won't bump it up, and you get 10.47 inches. Yeah? Alright, try this one. Hit pause, come back when you're ready. And hopefully you got 25.3. It says you have a wheel with a 34-inch radius, and you're marking it 2 places on the rim, here and here. And the distance between the marks is 15 inches, so from here to here is 15, that's arc length. And they want me to find theta in degrees. Alright, so if I set it up, 15 equals 34 times theta. To get theta alone, divide by 34, and theta equals, I don't think I can reduce that. Nope. 15 over 34 radians. So I got to turn that into degrees. I have 15 over 34 radians. To get rid of radians, I put it on the bottom. I want degrees on top. 180 degrees, pi radians. Radians cancel, and I end up with 15 times 180 over 34 times pi degrees. So 15 times 180, enter, divided by parentheses 34 times pi, and I get 25.277549979 degrees, and it says round to the nearest tenth, so the 2 bumps it up to a 3. Alright, we are at homework, so we are done. Happy homeworking, and I will see you next time.